Assalamu alaikum. Hi everyone. Welcome to the visual guide for flow simulation on a floating water wheel hydro turbine. If you are interested in following my steps, just keep watching the video till the end. Also, you can download this model where attached the link in the description box. My name is Noura and I will guide you. Before we start, make sure you have the simulation tool as you see here. If you don't, just go to small arrow next to option and click on it. After that, go to add-ins, select Solidworks simulation and press OK button. Now you are ready to use a flow simulation feature. First step we need to go through is wizard. And you can name your project. For example, turbine. After that, press next. Choose the unit system. I prefer to use SI unit and press next. We have here two types of analysis, which internal and external. Since we analyzing the flow across the turbine, we need to choose external analysis. Also, don't forget to check two options here. For the physical feature, we need to check gravity and rotation. For the gravity, make sure you keep x direction and z are zeros. For the y direction, you should write a negative 9.81. And you will get the arrow like this. Then press next. We have to select a fluid type, so we need to choose liquids by expanded and looking for the water. You can double click or you can add from here. So as you see, also we need to check cavitation and press next. Also next. In parameters, we are focusing on velocity parameters and it should be in x direction. So we assume the velocity is 12 meter per second. And you will get the blue arrow like this one. And keep y and z are zeros. After that, press finish. You will get this box as known as computational domain. It describes that our analysis and calculations for flow will be inside this area. Let me explain to you about this box. If you have another design, include internal analysis type, you can keep this box as default because it doesn't affect your calculations since the flow and your studies will be inside the model. On the other hand, if you have any design like ours, which include external analysis, you have to adjust this box to get best result. To resize the box, you can right click on computational domain and edit definition. You can resize it by changing the number here or you can play with these arrows. So I prefer to play with these arrows. So I need to go to top plane. and we need to change the orientation to front plane. Like this. So we are done. After that, press OK. Now we need to apply the rotation study by right-click on rotating region and insert rotating region. Select this shaft and make sure you select the shaft and not other parts. And angular velocity, we assume that we have 50 rad per second. But don't forget to put negative sign, because we need this shaft is rotate like counterclockwise. After that, press OK button. Other thing we need to do is to apply forces by right-click on goals, then insert global goals. We are looking for the forces in X, Y, and Z direction, for like this and this and this one. Z, and press OK. Now we need to run our study. Right-click on your project's name and run. Also, you can run from above if you have. Also click to run. You will get new window like this one. So it's preparing the design and prepare for the calculation. The calculation is starting. As you see here, it will take a while depending on your hardware and your connection speed. Let me pause the video to save your time. Now the solver is over. So close the window. As you see here, the result. So if we expand it, we will get many features that we can apply in model. So first thing we need to do is right-click on surface plots and insert. For the selection, we need to check use all faces, and for the contours, choose velocity. After that, press OK. Now right-click on Computational domain and hide. Also for the surface plot that we created, right-click on it and hide. Now the most important thing that we need to use is flow trajectories, where it shows the study of the flow. But before to use flow trajectories, you have to create reference plane as a starting point for the flow. You can go to back to assembly and choose the reference geometry, select plane, for the first reference you can expand this assembly and choose the right plane. For the second reference, so you can choose any point from this blade, for example this one, then press OK button. I already created the plane before, so I don't need it. I will cancel. Now we can use flow trajectory, so right click on it and insert. Now you can see the face that we created. We select the face. After that we need to change the number of points, for example 500 points. Now the shape of the flow we need to change from pipes to lines, for example at 1 millimeter for the width. Now press OK. As you see here, the velocity is shown. If you want to see how the flow is going inside, so you can right click on this part and select change transparency. Also for this one, we need to change the maximum velocity to the 12 for a sample, and the minimum velocity is 2. Also you can change from velocity by press the velocity, and you can change whatever you want, for example pressure, and then press this one. Also we can back to velocity. There is another way to display the movement of a flow by go to flow trajectories that we made it and right click on it and choose play. And if you want, you can press display style and, for example, as you see, the maximum velocity of the water described in red color, and when it reaches blade of the turbine we get changing in velocity. So let me stop the animation. As a result, it converts the energy of water flowing into mechanical energy. Sorry, and the generator for this one, it's convert this mechanical energy into electricity. The rotor is attached to turbine shaft and rotate at constant speed. We have reached the end of the tutorial, and I hope you get full of benefit and enjoyable. If you have any question or comments, please leave it in the comments. Thank you for the watching and have a great day.